Hello, and welcome to Aggressive Physics. Today is day 51, and what we're going to look at today is an extremely complex problem involving a bowling ball. This bowling ball, although rolling, we're going to consider to have sliding friction. So it's going to have kinetic friction. And what we are going to be able to do is solve what I consider to be an extremely complex problem. At the beginning of the course, all we had at our disposal was v equals d over t. We then went through the big five equations. We solved some projectile motion problems. We were able to analyze vectors and graphical analysis. And now we're talking about Newton's laws. And at this point in the course, we've covered a bulk of the mechanics section. And you're able to solve problems that are extremely complex. We have forces involved. We'll have inclined planes involved. We'll have friction involved. This problem will not only include all of the Newton's law chapter, but many of the concepts we've learned throughout the course. Remember to take your time drawing the free body diagram, and what I'll do is I'll show you how to solve the bowling ball dilemma. So let's look at it now. All right, now we're going to look at the bowling ball dilemma. And what we have is a 16-pound bowling ball rolling down a ramp, and the ramp has an angle of 25 degrees. Unfortunately, we have 16 pounds, so I want to get rid of that immediately. 16 pounds. I'm going to convert to kilograms, 1 pound, and I looked it up, 0.4536 kilograms. So if we take our calculator and we do 16 times 0.4536, we end up with 7.26. And that is kilograms. So now we know the mass of the ball. And the next thing we need to do is draw a free body diagram. So if I draw a free body diagram over here, I'm going to start with the ramp. I'm going to put 25 degrees there. I'm going to draw the box that represents the bowling ball, and I'm going to put 7.26 kilograms in the box. Now, our job in this problem is to find mu. So we're not going to look up what the value is. We have a ramp. We have the length of the ramp, which is 1.75 meters. We have the angle, which is 25 degrees, and we also know it goes 3.25 meters per second at the bottom. Now that information is going to clue me in that we're probably going to be able to find the acceleration with that information. Now I drew the bowling ball as if it were in the middle of the ramp, but the reality is it starts at the top and rolls down the entire ramp. So what I'm going to do is calculate the acceleration. Now the distance is 1.75. The VI, which is our hidden variable, is 0. And the VF is 3.25 meters per second. So let's find A from that. I'm going to use equation 5. VF squared minus VI squared equals 2AD. 3.25 meters per second squared minus 0 squared equals 2a, and then d, which was 1.75 meters. All right, 3.25 squared divided by 2, then divided by 1.75 gets me 3.02 meters per second squared. And that's my acceleration. So the acceleration, not a question mark anymore, 3.02 meters per second squared. Now that's going to go into my F equals ma equation. And what I'm going to do now is give myself a little bit more room and erase that calculation for the acceleration. That gives me some space to work. Now back to my free body diagram. I have gravity down. I have the normal force up. And because we're going to try to find the coefficient of friction, friction is going to oppose the motion. It's going to go back up the hill. Now anytime we have an incline, we want to blog. We're going to break the legs of gravity. We're going to get F parallel and F perpendicular. But before we do that, we need to find the force of gravity. So Fg equals mg, 7.26 kilograms times 9.8 meters per second squared. So 7.26 times 9.8, and I get 71.15 newtons. F parallel is Fg sine theta, so that's 71.15 newtons sine 25 degrees. So since it's already in my calculator, times sine 25, and I get 30.07. 30.07 newtons. For F perpendicular, I use Fg cos theta. So 71.15 newtons times cos 25. So 71.15 times the cosine of 25 gets me 64.5. Now, since there's no other forces up or down, the normal force is going to be equal to F perpendicular, and that will allow me to find friction. Now, normally we do friction is mu Fn. We know Fn, but we don't know mu. So we don't have enough information to find mu directly. So what we're going to do is now look at the parallel direction. And in the parallel direction, we have two forces. So if we sum the forces in the parallel and set it equal to ma, we're going to get F parallel minus friction equals ma. Now, most problems we've done so far, we've been finding the acceleration. This time we know the acceleration. We're going to put that there. And let's plug in what we know. 30.07 newtons minus friction equals m, which is 7.26 kilograms, times 3.02 meters per second squared. And we could find friction. And friction becomes, let's do 30.07. I'm going to bring that over here. Actually, I'll bring this term over. So I'll do minus quantity, 7.26 times 3.02, close that parentheses. And I have 8.1448. A little too precise, but that's what it says in my calculator, and I'll leave it at that. Now, to find mu, we do friction is mu Fn. We know friction, 8.1448 newtons equals mu, and we already have Fn because it's equal to F perpendicular, 64.5 newtons. So 8.1448 divided by 64.5 gets me a coefficient of friction to be 0.126. So even if we don't have mu, we can use other variables to help us solve for it. And that's the bowling ball adventure, or bowling ball dilemma, as I like to call it.